I am B. Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. In this session, we will discuss about the topic on problems on Stokes Theorem. Already we discussed in previous session Stokes Theorem theory part. Okay, now we will discuss that related problems. Okay, what is the statement of the Stokes Theorem? Stokes Theorem and Green's Theorem is same, but only the difference is the two are useful for transformation between line to surface integral only. But what is the difference between these two? Here we are using the here we are using the curl product. Okay, that means del cross f bar. In that Green's theorem, we are using the partial differentiation. That's the difference between Stokes theorem and Green's theorem. Mainly these two are useful for surface to transformation between line to surface integral, right? Okay, now I'll start with the first question from the Stokes theorem. That is the first question, verification. What is the first question? Verify Stokes theorem for the function f bar is equal to x square I bar plus xyj bar integrated around the square in the plane z is equal to 0, whose sides are along the lines x is equal to 0, y is equal to 0, x is equal to a and y is equal to a. Okay, here verify the Stokes theorem for the function f bar, that is x square I bar plus xyj bar. Here what is the circle? That means circle means here the it integrated around the square. Okay, what is the curve here? Square. In the plane z is equal to 0. What are the sides for this square here? X is 0, y is 0, x is equal to a and y is equal to a. Okay, then for the given question, first f bar is x square I bar plus xy bar. From the given lines, first I'll draw the square. If z is equal to 0 means that the square bar is on the xy axis. Okay, first I'll form the vertices from the given lines. X is 0 and y is 0, x is equal to a and y is equal to a. From this, first I'll take the vertices. At x is 0, for that case, okay, y is also 0. At x is 0, okay, and for the case I'll take a, that is a. Next, at y is 0, okay, at x is a, for that case I'll take y as 0. And the next one, at x is a, for that case I'll take y is equal to a. From these vertices, first I'll draw the diagram for that. At a, what is the point of a here? 0, 0. From that 0, 0 means that is the origin point. At x is 0, y is 0. And the next one, at x is a, but y is 0. At x is a, but y is 0. Where is that point? Okay, this is x is equal to a and here I'll take y is equal to a on y axis. Okay, now I'll take the point at x is a and y is 0. That means this is the point. At x is a and y is equal to 0. That is a comma 0. Next point, I'll take x is equal to a and y is equal to a. That means here x point is a and y is a, where it is intersecting this point. Let us assume that as the B point, a comma a. And one more point, at x is 0, y is equal to a, where it is at x is 0 and y is equal to a means that as the C point, there y is a and x value as 0. Let us assume that as the C. Okay, now draw the diagram for that. Just join these all points, that is OA BC form. OA BC form. Okay, from the given lines, okay, we got the diagram that is in the form of a square. Okay, from that here, once you observe from O to A, what is the common point? Here it is on x-axis means there y is equal to 0. From A to B, okay, from A to B, what is the common point here? X is equal to A. Okay, and from B to C, And from B to C, what is common point? Y is equal to A. And from C to O, okay, from C to O, what is the common point here? Here the common point as y on y-axis, x is equal to 0. Now from the diagram here, what are the limit points for x? X limit points 0 to A. And what about the y limit points? Y limit points 0 to A. Y limit points also 0 to A. Okay. Now, okay, from the diagram we got the x points and y points. After that, by the Stokes theorem, what is the statement of the Stokes theorem here? Integral of S del cross f bar dot n bar ds is equal to integral C f bar dot dr bar. That means what? What is the meaning of that? Surface is transformed to line or line is transformed to surface. Okay. First I'll take the LHS part of the theorem, that is integral S del cross f bar dot n bar ds. From that, what is del cross f bar? Okay, first I'll calculate the del cross f bar. Del cross f bar means what? This is the cross product with del with f bar. What is the formula of curl f bar or del cross f bar? Okay, del cross f bar is equal to what? Curl f bar. That is equal to I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. And what is f bar here? F bar is x square I bar plus xy j bar. From that, here I'll write here k bar dot 0 into 0. That means here what is I bar coefficient? This is f bar from the given question. That is from the I bar coefficient is here x square and the j bar coefficient is xy and the k bar coefficient as 0. Okay, that is this one. Okay, now find the determinant of the curl f bar here. That is I bar into dou by dou y of cross product, neglecting the corresponding row and column. The remaining cross product dou by dou y of 0 minus dou by dou z of xy. Dou by dou z of xy. Minus j bar into neglecting that corresponding row and column, and the remaining part dou by dou x of 0 minus dou by dou z of x square plus k bar into, okay, neglecting the corresponding row and column, dou by dou x of xy minus dou by dou y of x square. From that first part I bar into 0 minus with respect to z, that as 0 minus j bar into 0 dou by dou z of x square also 0 plus k bar into dou by dou x of xy, that is y. Okay, x as 1 minus dou by dou y of x square 0. Therefore, what about del cross f bar here? K bar of into y. Therefore, del cross f bar is equal to much? K bar of y. Okay, now I'll take the LHS part from the theorem, that is integral S del cross f bar dot n bar ds. Okay, here what is the unit normal vector? Here unit normal vector n bar is equal to k bar. Okay, now why? Because here once you observe from the theorem, from the given conditions, here directly z axis as 0. That means it is completely on xy axis, right? For that case, I'll take here ds is equal to dx dy, that outward unit normal vector as k bar. Okay, n bar is equal to k bar. Now, therefore, integral S del cross f bar dot n bar ds is equal to integral S del cross f bar is equal to how much? K bar into dot y into y dot, what is n bar? K bar into what is ds? Dx dy. Therefore, this is equal to what? Integral of k bar dot k bar, that is 1, and y into 1 into dx dy. Once you observe here, n bar dot k bar is equal to d into ds is equal to what? Dx dy. That one will I am explaining now. And R is the region bounded by the further square. For that case, here we got double integral of surface integral means double integral form. That is, here it is and ds is in xy axis. For that case, what are the limits? Already discussed in the previous slide. X limits are 0 to a and y limits also 0 to a. Okay, here integrate either with respect to y or xy because both the limits are same. That means first I'll integrate with respect to y, that is y integration as y square by 2, limit points 0 to a, and next 0 to a dx. Okay, then substitute here a square by 2 minus 0 integral of 0 to a dx. That is a square by 2 into dx integral 0 to a. Okay, now integrate with respect to x. That integration as with respect to x, a square by 2 as constant. There one integration as x. That limit points are 0 to a. That is a square by 2 into a minus 0. That is a cube by 2. Therefore, from the LHS part of the theorem, integral S del cross f bar dot n bar ds is equal to how much? A cube by 2. Okay, this is the first part of the verification. Okay, from that, okay, now we have to find out line integral form from the given conditions of the question. Okay, that is RHS part here. Here RHS part is integral C f bar dot dr bar. Okay, integral C f bar dot dr bar. What is this? It is line integral along the square. Okay, square means here how many parts are there and how many lines are there? OA, AB, BC and CO. OA, AB, BC and CO. Once again I'll draw the diagram here. That is, this is O, A, B, C. This is 0, 0 and 0, a, 0 and a, and this is 0, a. Now, I have to calculate the line integral along the square. Here the square is having 4 parts. That the first line is OA and the second line is AB and the third line is BC and the fourth line is CO. Okay, now therefore, integral C f bar dot dr bar is equal to what? Integral OA f bar dot dr bar plus integral AB f bar dot dr bar plus integral BC f bar dot dr bar plus integral CO f bar dot dr bar. Now I can calculate each and every line, okay, line integral value. First line along OA. Along OA means once you observe here y is equal to 0. Along OA y is equal to 0 and from the question directly z is also 0 and the differentiation, okay, and the differentiation y differentiation is 0, that is dy as 0 and z is 0 means the differentiation is also 0. Therefore f bar dot dr bar. What is f bar and what is dr bar? Okay, first I'll calculate f bar dot dr bar here. F bar is x square I bar, okay, x square I bar plus xyj bar into what is dr bar? In the theory I discussed, dr bar is the position vector. Okay, from that dr bar is equal to what? dxi bar plus dyj bar plus dz k bar. dxi bar plus dyj bar plus dz k bar. Okay, then dot product of the two vectors x square I bar coefficient is x square and here I bar coefficient is dx plus j bar coefficient here xy and here j bar coefficient as dy and k bar coefficient here 0, there also 0 into dz as 0. Therefore, f bar dot dr bar is equal to what? X square dx plus xy dy. This is f bar dot dr bar. But from the along line OA, what are the conditions here? Y is equal to 0 and z is equal to 0. Then substitute here. That is, z by is 0 means x square dx plus x into 0 into dy as 0. That is x square into dx. That is f bar dr bar along the line OA. Okay, now we have to calculate the line integral along OA. That is, okay, once you observe, after the calculation of f bar dot dr bar, it is complete in terms of x. Therefore, from the diagram, we got the limit points. What are the x limits for that? X limits 0 to a. X limits 0 to a. Therefore, integral of x square dx is what? X cube by 3. X square dx means x cube by 3 and the limit points are 0 to a. That is a cube by 3 minus 0. This is equal to what? A cube by 3. That is the first answer for the along OA line integral value a cube by 3. Okay. Next line along AB. Along AB. What are the conditions for the along AB from the diagram? Along AB here x is equal to a. Okay, therefore along AB here x is equal to a. For that all cases z is equal to 0. It is directly in the question z is equal to 0. And the differentiations dx is 0 and the dz is also 0. Okay, therefore, what is f bar dot dr bar? Already here it is there. F bar dot dr bar is x square dx plus xy dy. xy dy. X square dx plus xy dy. From that, x is equal to a and the derivative is 0. Okay, that means here x is equal to a square into dx as 0 plus x is a into y into dy. Okay, once you observe, after substituting all conditions in f bar dot dr bar, therefore f bar dot dr bar is what? Ay dy. That is f bar dot dr bar. Okay, once you observe f bar dot dr bar completely in terms of y, then I can substitute the limit points also y points. That is integration of f bar dot dr bar. That is y limit points here 0 to a from the diagram. Okay, y limit points 0 to a y into dy. That is y integration is y square by 2 and the limit points are 0 to a. That is a square by 2, okay, minus, okay, here already 1a, I'll take outside, that is a square by 2 into here a minus 0. That is a cube by, that's along AB line integral value 1 by 2 into a cube. 1 by 2 into a cube. Next one, third line along BC. Along BC means from the diagram y is equal to a. From the diagram y is equal to a and the z is also 0. And the differentiation y is equal to a differentiation is 0 and the dz value is 0. That means here along BC f bar dot dr bar. What is f bar dot dr bar? X square dx plus xy into dy. X square dx plus xy into dy. Now substitute all conditions here. X square is x square into dx plus x into what is y here? A. And what about dy? 0. Therefore, f bar dot dr bar is equal to what here? X square dx. X square dx. Therefore, integral C f bar dot dr bar is equal to, if f bar dot dr bar completely it is in terms of x, therefore the limit points for that. Okay, once you observe along BC. Along BC means what are the limit points? A to 0. Limit points along BC a to 0. Okay, here x square. Okay, that is this step. And next, now integrate with respect to x, that is x cube by 3. X cube by 3. Substitute the limit points, that is 0 minus of, okay, a cube by 3. Therefore, minus of a cube by 3. That is along BC minus 1 by 3 into a cube. Minus 1 by 3 into a cube. That is along BC. Next, last line from the square here along CO. Along CO, what are the conditions from that? Here x is 0, z is equal to 0. Okay, along CO x is 0 and z directly 0, and the derivatives dx is 0 and dz is also 0. Then substitute what about f bar dot dr bar here. F bar dot dr bar is equal to, okay, x square dx plus xy dy. X square dx plus xy dy. Therefore, x square is 0, x is 0, the derivative is 0, and x is 0 and y into dy. Therefore, f bar dot dr bar is equal to what? Directly it is 0. Integral CO f bar dot dr bar is equal to integral a to 0, 0 into dy. That is 0. Okay. Now add all the line integral values along OA, AB, BC and CO. Okay. Therefore, integral C f bar dot dr bar is equal to here. What about the first one? Okay. Along OA, that is a cube by 3. And next along AB, that is 1 by 2 into a cube. Next along BC, that is minus 1 by 3 into a cube. Minus 1 by 3 into a cube. And next along CO, that is 0. Okay, here minus 1 by 3 a cube and plus 1 by 3 a cube cancel. Therefore, the final answer is 1 by 2 a cube. Okay, that is 1 by 2 a cube. Once you observe the line integral value, integral C f bar dot dr bar is equal to what? 1 by 2 into a cube. From that LHS part of the theorem, that is, okay, that is curl f bar dot n bar ds or del cross f bar dot n bar ds integration of that is also a cube by 2. Therefore, in both the cases, okay, answer is same, that is a cube by 2. Therefore, integral s del cross f bar dot n bar ds is equal to integral c f bar dot dr bar. Therefore, this is a cube by 2 and this is also a cube by 2. Therefore, here Stokes theorem verified. Therefore, Stokes theorem verified. Okay, this is the first question from the Stokes theorem. Okay, and next I'll go through the second question from the Stokes. That is, verify Stokes theorem for the function f bar is equal to x square plus y square into I bar minus 2xy z bar taken round the rectangle bounded by the lines x is equal to plus or minus a and y is equal to 0, comma y is equal to b. Okay, verify Stokes theorem for the function is here x square plus y square into I bar minus 2xy into j bar taken over the rectangle. In the previous question we are considering with a square, here rectangle, it is bounded by the lines. What are the lines there? X is plus or minus a and y is equal to 0, comma y is equal to b. Okay, from the given lines, first I'll take the vertices. Okay, okay, what are the vertices for that here? What are the x points? X is equal to a comma minus a and y is equal to 0 comma b. From that, first I will take the vertices at x is equal to a. From that case, y is 0. That is a comma 0. Okay, next at x is a and y is equal to b. That is a comma b. And the next point at x is equal to minus a. From that case, y is equal to b. And next at x is equal to minus a. From that case, y is equal to 0. Therefore, the last vertices here minus a comma 0. Okay, therefore, from the conditions, we got the vertices a comma 0, a comma b, minus a comma b, and minus a comma 0. Okay, therefore first I'll draw the diagram for that. Okay, along first one. Okay, this is okay. This is the diagram for that. Along first point at a comma 0. At a comma 0 means it is in x-axis. This is a and here 0 comma 0. Okay, that is at a, x point is a and y is 0 means it is intersecting there. That is a point. And next at a comma b. At a comma b means here b point I'll take. Okay, and here minus a and there minus b. Okay, here the next point intersecting, where that intersecting at x is equal to a and y is equal to b means at x is a and y is b means this is the intersecting point for b. Okay, next, what about the next point? At x is equal to minus a and y is equal to b. X is equal to minus a means it is on negative side of the x-axis. That means where is it? Here, minus a, and y is equal to b means there minus a comma b. Okay, and the last point here minus a comma 0. At x is minus a and y is 0, that is d point, that is minus a comma 0. Okay, that is the intersecting point at d. Just draw the just join these all lines, that is first line as AB, next line as BC, and the next line as CD, and the next line as D to A. Okay, once you observe, after joining all lines, the rectangle is on XY axis only. That means for this question, what about Z value? Z is also 0. Okay, from the diagram now I have to verify Stokes theorem for the function f bar is equal to x square plus y square into I bar minus 2xy into j bar. Okay, first, what is the theorem statement here? Okay, line integral is equal to the surface integral form. Here, what is the form of the line integral? Integral c f bar dot dr bar is equal to what? Integral s curl f bar dot n bar ds. For this question, first I'll calculate the line integral values. What are the lines here? Rectangle means there also 4 lines. Okay, 4 lines. What are the 4 lines here? AB, BC, CD and DA. AB, BC, CD and DA. For that first, I'll take the F bar dot DR bar. I'll take F bar dot DR bar. What is the given function here? X square plus Y square into I bar minus 2xy j bar. X square plus y square into I bar minus 2xy into j bar dot. What about dr bar? Position vector, that is dxi bar plus dyj bar plus dz k bar. Product of these two here, I bar coefficient as x square plus y square into dx minus j bar coefficient here minus 2xy there dy, that is minus 2xy into dy. Therefore, directly f bar dot dr bar is equal to what? X square plus y square into dx minus 2xy into dy. That is this one. Now I'll calculate the line integral along AB, BC, CD and DA. If you know the f bar dot dr bar for the first part only, easily we can find the line integral along AB, BC, CD and DA. Okay. Now along AB. Along AB, what are the conditions for along AB here? Once you observe, along AB, x is equal to a. Along AB, x is equal to a and the derivative is 0. And the derivative is 0. 0. That is integral c f bar dot dr bar is equal to, okay, what about f bar dot dr bar? From the previous step, x square plus y square into dx minus 2xy into dy. x square plus y square into dx minus 2xy into dy. Now substitute these all conditions here. X is a, that is a square plus y square into dx as 0 minus 2 into x as a, y into dy. After substituting all here, we got minus 2ay into dy, that is f bar dot dr bar. Okay, from that, once you observe that part as in terms of y only, okay, in terms of y, then you can substitute the limit points in terms of y, that are integral of cf bar dot dr bar, that is integral ab is equal to integral y is equal to 0 to b, that is equal to here minus 2a into y square by 2. Okay, y integration is y square by 2 and the limit points are 0 to b. Then substitute there, here 2 cancel directly, minus a into b square minus 0, that is minus ab square minus AB square. Okay, therefore along AB, okay, along AB, line integral value how much? Minus AB square. Next, along BC. Along BC, what are the conditions from the diagram? Y is equal to B. Okay, and the derivative is 0. And the derivative is 0. From that, okay, first integral C f bar dot dr bar. What about f bar dot dr bar here? X square plus y square into dx minus 2xy into dy. That is equal to here. What are the conditions? Y is equal to b. Then substitute there. That is x square plus b square into dx minus 2x into y as b, but derivative as dy as 0. That is x square plus b square into dx. This is f bar dot dr bar. Once you observe, after the dot product of f bar dot dr bar, it will converted in terms of x. From the diagram along BC, what are the limit points here? A to minus a. Limit points a to minus a. Now integrate with respect to x, that is x square integration as x cube by 3 plus b square into x. Limit points a to minus a. A to minus a. Now substitute all limit points here. Upper limit as minus a and the lower limit as a. Directly it is minus 2a cube by 3 minus 2a b square. Minus 2a cube by 3 minus 2a b square. This is along BC. Okay. Next one. Along CD. Along CD, from the diagram, what are the conditions for that? X is equal to minus a. Along CD, x is equal to minus a and the derivative is 0. Therefore, integral f bar dot dr bar is equal to, what is f bar here? X square plus y square into dx minus 2xy into dy. X square plus y square into dx minus 2xy into dy. From that, here, what is x here? Minus a square. Substitute there, minus a whole square plus y square into dx as 0 minus 2x into x is how much here? Minus a into y dy. That is equal to what? First part 0. Next one, 2ay into dy. That is f bar dot dr bar. Once you observe here, f bar dot dr bar is in terms of y, then you can take the limits as b to 0. What are the limit points for that? B to 0. Then substitute here, limit points y as b to 0, 2ay dy. Okay, that is 2a into y integration is y square by 2 and the limit points b to 0. Therefore, 2 cancel, a into, okay, 0 minus b square. That is minus a b square. That is along CD minus a b square. Next, okay, 3 lines are completed. Next line, that is the last line from the rectangle, that is along DA. What are the conditions for along DA from the diagram? Along DA, here once you observe, along DA here, which one has 0? maybe y is equal to 0. Okay, y as 0 and the derivative dy is equal to 0. From that, what is f bar dot dr bar? F bar dot dr bar is equal to x square plus y square into dx minus 2xy into dy. From that, x square y as 0 into dx minus 2 into x into dy and the derivative also 0, that is x square dx. Along CD, f bar dot dr bar is in terms of x, therefore the x limits here from the diagram minus a to a. Minus a to a. Now integrate x square integration as x cube by 3, x square integration as x cube by 3 and the limit points are minus a to a. Then substitute the limit points, upper limit as a cube by 3 minus of minus a cube by 3. That is a cube by 3 plus a cube by 3. This is equal to what? 2a cube by 3. This is the along dA, okay, line integral value what? 2a cube by 3. Now add all 1, 2, 3, 4 lines. That is, what are the lines here? Along AB, BC, CD and DA. Add all the values here. The first line value is, okay, first line is minus AB square and the next one is minus 2a cube minus 2ab square and the third line has minus ab square plus the fourth line has plus 2a cube by 3. Okay, here what are the possibilities for that? Here anyone is cancelled. Okay, once you observe here, minus ab square minus ab square minus 2ab square, that is minus 4ab square, minus 4ab square. Here see, minus into minus plus 2a cube by 3, this is plus, okay, this is minus 2a cube by 3 plus 2a cube by 3. Okay, these two are cancelled, therefore minus 4ab square. Therefore line integral on rectangle integral CF bar dot dr bar is equal to how much? Minus 4ab square. Okay, that's the first part of the Stokes theorem. Let us start with the second part of the Stokes theorem, that is the surface integral. That is integral S curl f bar dot n bar ds. F bar dot n bar ds. Here, what about unit normal vector? Here vector perpendicular to the, here the vector is perpendicular to the xy plane, that is n bar is equal to k bar. Okay, therefore here first I'll calculate curl f bar. Curl f bar is equal to what? I bar, j bar, k bar and the formula dou by dou x, dou by dou y, dou by dou z, and what about f from the vector I bar coefficient as x square plus y square. What about the given question f bar? X square plus y square into I bar minus 2xy into j bar. There I bar coefficient as x square plus y square and j bar coefficient as minus 2xy and the k bar coefficient as 0. Therefore, okay, determinant of that is I bar into neglecting that corresponding row and column, that is dou by dou y of 0 and dou by dou z of minus 2xy also 0. Minus of j bar into neglecting the corresponding row and column and the remaining part dou by dou x of 0 minus dou by dou z of x square plus y square also 0 plus k bar into neglecting the corresponding row and column and the remaining part dou by dou x of minus 2xy, that is minus 2y. Minus of dou by dou y of x square plus y square, that is what? 2y. Therefore, here first I bar 0 and next 0 minus 4y k bar. Therefore, what about curl f bar here? Minus 4y k bar. Okay. Then since the rectangle lies in the xy plane, for that unit normal vector as k bar and ds is equal to dx dy. Okay, from that this is equal to minus 4y k bar. And next, therefore integral s curl f bar dot n bar is minus 4y into k bar and the unit normal vector n bar is k bar into dx dy. Then what are the limits on xy axis? X limits are minus a to a and the y limits are 0 to b from the diagram. X limits are minus a to a and y limits are zeros. Here k bar dot k bar is equal to how much? 1. From that minus 4y into dx dy. Minus 4y into dx dy. Okay. Next I'll integrate with respect to either x or y. First I'll integrate this with respect to x. That is minus 4y I'll take outside and minus 4 will take outside and the remaining part here 1 integration has x and the limit points are minus a to a into dy. Okay, after substituting the limits here, integral of minus 4 into y into, after substituting the limits, upper limit as a minus of minus a, that is plus 2a. That's why here we got minus 4 into 2ay into dy. Minus 4 into integration of y is 0 to b 2ay into dy. That is equal to minus 4a and y integration, that is y square by y integration as y square by 2. Okay, here I'll write that step. Minus 4 into 2a into y square by 2. Limit points 0 to b. Here 2 cancel, we get minus 4a y square. Limit points are 0 to b. Limit points are 0 to b. Then substitute in place of y, that is minus 4ab square. Our limit as 0. That is minus 4ab square. Minus 4ab square. Okay, therefore from the second question, surface integral value, integral s curl f bar dot n bar ds is equal to how much? Minus 4ab square. Okay, therefore from the second equation and the third equation, what is second equation? That is after adding the line integral values. Okay, from that we got minus 4ab square, and from third equation, that is integral s curl f bar dot n bar ds is equal to what? Minus 4ab square. Therefore integral c f bar dot dr bar is equal to integral s curl f bar dot n bar ds is equal to how much? This is minus 4ab square and this is also minus 4ab square. For the second question also, both the line integral is equal to surface integral. If the two are equal, then Stokes theorem is verified. This is the concept of the second question. Okay, for the first question we discussed the curve on a square. For the second question we discussed on line integral along rectangle. That is rectangle also 4 parts and the square is also 4 parts. Okay, from the two cases we got Stokes theorem is verified for the two cases. Therefore, this is the concept of the Stokes theorem. Okay, this is the concept of the Stokes theorem. Next class we will discuss other related topics on vector calculus. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.